Welcome back. Now, we're on section 8, and just as in working with the future value, where you use tables and a formula for the future value equals the principal times the quantity 1 plus the interest rate per compounding period, and that quantity is all raised to the total number of periods. We can do the same thing with the present value. So all we're doing is taking the present value or the future value formula. All right. So they called it A equals the present value or the principal times 1 plus the compounding, little I is the compounding interest rate per compounding period, raised to the small n, which was the total number of compounding periods. So if we just manipulate this, we can figure out what the present value is. All right, so if we divide both sides by 1 plus I, we can derive, raised to the nth power, we can derive the formula, the present value equals the future value, all right, or yes, the future value, the compounded amount, divided by the quantity 1 plus lowercase I, which is the compounding interest rate per period, raised to the total number of periods. So we can use that formula now. So all we need to know is what is the future value, or the compounding amount, what is the interest rate per compounding period, so if it's quarterly, what is it for each quarter, and what are the total number of periods. And we can use this formula to figure out what the present value is that will be needed. All right, so you can see here's the formula that they're using right now, and they explain it all. PV is the present value, A is the compounded amount, I is the interest rate per period, and it's expressed as a decimal, not as a percentage. N is the total compounding periods, and that's the years times the periods per year. Then they give you the steps, and then they give you the keys in order to do this problem in your calculator. All right, so they say add 1 to the interest rate. So remember, please excuse my dear Aunt Sally. Parentheses first, so we got to do the denominator. All right, so 1 plus the interest rate. So 1 plus the interest rate, that equals, and whatever that amount equals, we now raise that to the n power. So please, if you haven't figured it out already, figure out how to use your exponents. On the calculator that I'm using, I know that I call it the caret. It's a little arrow that points up. Some of you might have, here they have a y to the x. All right, so that's your exponent button. So then you raise it to the nth power, and whatever that equals, save it to your memory. If your calculator has memory, that's awesome. All right. If you can't figure out how to save that number into the memory, that's why they're saying memory plus, then just write the number down and write as many decimal places as possible, because that will give you the most accurate answer. Then once you save that amount, whatever the 1 plus I raised to the nth power, once you save that, then you take the future value, or the compounded amount, and divide it by what you just saved to memory. So we're taking the compounded amount and dividing that by 1 plus I raised to the total raised to the nth power. And when you do that, that should give you the present value. So the keystrokes are a little different on your calculator. You have to pay attention to the order of operations. So we got to do the parentheses first and the exponent, which is in the denominator. But then we have to punch in the numerator, which is the compounded amount, and then divide it by what we got. All right? So if you have a programmable calculator, that makes it easy. You put it in the amount, put the division sign, and then with parentheses, if you have the ability to put parentheses in, that helps. All right, so you would actually put 2 sets of parentheses to make that work. Okay, so let's look at the example. All right, example 8. Using the present value formula to calculate the present value of $3,000 if the interest rate is 8% compounded quarterly for 6 years. So quarterly is 4. So the total number of periods, or little n, is going to be 4 times 6, which is 24. Okay, and that's what they figure out here, 6 times 4. The exponent n is 24, 6 times 4. And then we have to figure out the interest rate per period. So again, if it's quarterly at 8%, 8% divided by 4 should be 2. All right, 8% divided by 4, if you can see it there, should be 2. All right, so we know what I is. So if we plug that into our formula, present value is $3,000 divided by the quantity 1 plus 0.02 raised to the 24th power. So we add 1 plus 0.2, so it's 1.02. Then we raise it to the 24th power, which is 1.608437249. Most calculators only give that many digits, which is good. And then we take 3,000 and divide 1.608437249. And the present value should be $1,865.16. And that's what we should get in 6 years if it's compounded quarterly at 8%. That's how we would get our $3,000. So they give you the calculator sequence here, adding 1 plus 0.02, and that should, whatever that equals, you raise it to the 24th power, and then you save it, either write it down or save it in your calculator, and then you take the compounded amount, 3,000, and divide that by whatever number you saved, or the amount you wrote down. And that should be equal 1.86516. Remember, just like in the future value, this 1 plus I, that quantity raised to the n power, you're determining your factor from the table. All right? You're determining your factor from the table. All right? Okay. So, that's your example. Okay? We're going to look at try it exercise 8. Please practice this. Please use the formula. This is a good practice. So, Sam and Rosa want to accumulate $30,000 in 17 years from now as a college fund for their baby son. Another great example of what you can do here. So they're going to use the formula. Use the present value formula to calculate how much they must invest now in a lump sum at an interest rate of 8%, compounded semi-annually, so every 6 months, twice a year, to have $30,000 in 17 years. This is a great example. All right, great example. So if you guys just take a moment, figure that out, and I will come back with the answer.